Hello everybody, we're here today to talk about Kubernetes operators and how to quickly get started with them. We wanted to go over a few different tools that will help you quickly bootstrap Kubernetes operators and talk about kind of what they do, the relation between them, and do some quick demos so you can kind of get a hands-on feel for how they operate. There are three specific projects we want to focus on. The first one being Kubebuilder. Kubebuilder is essentially a way to scaffold out quick Kubernetes APIs and Kubernetes code to get you started writing your own operators. They've got a fantastic book that they have written that has just a ton of information in there that's very, very useful. The second project we really want to go over is called Operator Sdk. Operator Sdk is sponsored by Red Hat and kind of builds upon the Kubebuilder, what Kubebuilder does. It actually is a plugin-based model to the Kubebuilder project. It also has additional features that allow you to do things like Helm and Ansible as well. They also have some pretty fantastic documentation here for working with operators and how to quickly get started with them. And the third and final project we want to talk about is one we've been incubating and working on over the past several months called Operator Builder. Operator Builder is designed to, again, take what Kubebuilder has done. It is a plugin to the Kubebuilder project and take it a step further to give you an actual working Kubernetes operator with basic create, update, and delete functionality out of the box. Additionally to Kubebuilder, we are part of VMware, so we have developed a Fling that will act as a plugin to the Tanzu CLI if you are a current Tanzu CLI customer. The first tool we want to go over here is Kubebuilder. First and foremost, I want to point out that we're not going to go through the code base and take a look deep into the code base, but I do want to point out that Kubebuilder is publicly available on github.com at github.com/kubernetessig/kubebuilder. I also do want to remind you that there is a fantastic book that Kubebuilder has out there. It talks about all practical things with Kubernetes controllers and reconciliation, as well as how to use the Kubebuilder project itself. But it does have additional info if you're interested on the basics and really kind of diving deep into the Kubernetes reconciliation process. Over in the left pane here, I've got a kind of an empty Kubebuilder directory. Just want to kind of go through a demo so you can kind of get a look and feel for what Kubebuilder actually offers you as it relates to building operators in Kubernetes. So I have carved out a couple make targets here to make this a little bit easier to demo. The first thing I want to do is I want to actually initialize a new Kubebuilder project. So I'm just going to run my make target and we can see what it's actually running. What it's actually doing here is it's actually initializing a Kubebuilder project with the domain apps.acme.com. This is the domain you would commonly see in a custom resource definition with a project name of Kubebuilder demo, which is just metadata that this project needs to have on it. And the repo, I'm just using the repo that all of this code is going to be stored in, which is github.com scottd018, which is my repo /demos. You'll see it scaffolded out something in the tree over here on the left. We don't really have much here yet, but we do see this nice helpful command that says next define a resource with Kubebuilder create API. So we don't really have much here other than a couple manifests, some manager manifests, really not a whole lot. Nothing really that would produce a functional working Kubernetes operator per se. So we can go next to the actual create API command, which I also have a make target for, and let Kubebuilder generate its code base. And while we run that, we can see that we are running the Kubebuilder create API command that the previous command told us to run. We are creating a group of demo, which goes under the previous domain that we initialized the project with. Our version is v1 alpha 1. The kind of this custom resource that this operator is going to be managing is Kubebuilder, and we are going to scaffold out the controller and resources as well. So as we can see, we now have a little bit more within this project. We have an API directory. It has the version that we generated, and I can see that I now have some code that's been scaffolded out here. So I've got these Kubebuilder types, and I can see that my entire spec for my resource that I want to reconcile is here. And you can see that really we don't have anything other than just really the standard Kubernetes things such as a spec field, a status field, the common metadata fields, nothing really that would give us an actual API that would work with. But we do have things like this Kubebuilder spec, which has a foo, which is kind of a good starting place for managing and creating your API. We also have a config CRD directory, and we see there's nothing really in there right now other than a couple customization files in there. We've also got some samples that would be like a sample CRD, and we see that I don't even have anything here in the spec that would be part of this custom resource. But this is how I would manage it. I could submit this resource to the cluster, and my operator would take over and run through its reconciliation loop. I can also hop into the Kubebuilder directory here, and I can make manifests, and that will actually generate the custom resources, which I can submit to the cluster and extend my Kubernetes API with, which now I should have a CRD bases folder, and the actual custom resource definition has been scaffolded out for me. So essentially what Kubebuilder gives me is a set of custom resources that I can submit to the cluster, a sample of how I would manage those, some scaffolded API code here, which I could add additional fields to if I wanted to. I could say, you know, this is a bar string, and I could add the Go tags that I need to that I needed to. So I could manage my API this way. In addition to that, I've also got this controller file, which is the actual controller loop that's actually running. So we can see that it's running this reconcile method, and for Kubebuilder, we just get a comment that says your logic here. So I could write whatever Go logic I want that happens during that reconcile loop whenever that custom resource that's submitted to the cluster. In this case, we're talking about this sample resource here. When that gets submitted to the cluster, I can run my Go logic to perform my reconciliation process. But as you see here, there's nothing stamped out for me. I'd have to write that all on my own from scratch. So it's super flexible, but I got to start from bare bones nothing, bare minimum, and I would have to write this all from scratch, which is not a big deal in certain situations. But also important to note before we move on to Operator Sdk is that this right here is the foundation for both Operator Sdk and Operator Builder, which are the two projects we're going to follow on and talk about. So Kubebuilder implements a plugin model. They use the plugin model within their own code base, and Operator Sdk uses that plugin model to implement their features, as well as Operator uses that same plugin model to implement the features that we've chosen to work on. So that's a quick overview of Kubebuilder, what it gives you. Next, we're going to hop over to Operator Sdk and take a look at that. Next, we're going to go over the Operator Sdk Framework, which is a plugin which uses the Kubebuilder plugin model to extend the Kubebuilder framework to maybe add additional functionality to Kubebuilder. Specifically, on the right pane here, I've got the code base for Operator Sdk. Again, we're not going over the code base in depth. Just wanted to point out that this code base for Operator Sdk is available at github.com/operator-framework/operator SDK. And in addition to that, they do have some pretty good documentation on how to get started with it. They've got, this is linked off of their GitHub, and also a very good guide and tutorial for some of the features that they provide. Just want to point that out real quick. We can go through a functional demo and take a look at what Operator Sdk provides as compared to what Kubebuilder provides. First and foremost, we want to go compare the Go integration as compared to what Kubebuilder does. So we'll go ahead and take a look at that real quick. I can just run my make target real quick, and I can see that the Operator Sdk is running with the same flags that Kubebuilder did, essentially. So that just kind of outlines the fact that this is coming from the Kubebuilder framework. So a lot of this stuff is going to look really super familiar. Same thing here. I run the same create API command to get my Go code base. This is going to be quick because this is pretty similar to what Kubebuilder does. If I create that API, I'll go ahead and pop into the APIs directory while that's creating. You can see that we essentially have the same thing we did with Kubebuilder. We've got a spec with this sample foo variable there, a status field. We can insert additional fields if we want to update the API. If I go to the controllers, I can see that my control loop is the same thing. Basically implement my logic here in Go, whatever I can write in Go, I can have my controller essentially do for me. So this is looking, really similar to the Kubebuilder. It's not that much different. It doesn't extend the Go integration that much. So I'll go ahead and clean this out real quick, and then we'll take a look at the other things that Operator Sdk does that Kubebuilder doesn't do. Those two things, as you'll see here, are Ansible and Helm, meaning that they have an actual Ansible and Helm integration. So if I run my make target for Ansible, I can go ahead and see that I ran the init command. Again, it looks very similar, except for this time I'm using the plugins Ansible flag for the Operator Sdk command. And you'll see it generated a tree that looks very similar to, if you're familiar with Ansible, things that we see a lot, molecule for testing, the playbook, roles that can be reused, but there's nothing really that's functional here. So if I extend this, I can go ahead and run the create API command, just like I did with the Go version. I can go ahead and create that, and we can see that it runs exactly the same thing as we did before, except for now I'm running it with the generate role flag, which is going to generate an actual scaffolded role for my kind, which in this case is an Operator Sdk. And you can see this looks exactly like what an Ansible role would look like for those who are familiar with it. You've got the default variables, any templating, the tasks that run, handlers, etc. Important thing is here, this is obviously an Ansible where the bulk of the work is done, and I can see that I've got nothing here, but I could write whatever I wanted to here. Just take a look at this. I've got an Ansible playbook here, so I've got just one that just prints out a statement that says hello world. If we were to use this this task per se in this set of tasks here, my reconciliation loop would essentially just print out a hello world statement, and that would be it. The other important thing to note here is we don't see a controllers directory with Go code that's calling this playbook, so how does that get created? And the answer to that is in the Docker file. We can see that when Docker builds this image, we are using the Ansible operator image, which is essentially running whatever playbooks you have via your custom resources in a reconciliation that is based upon these tasks within your roles. So that's the important thing to note there. So this generally just looks just like a typical Ansible project here. Everything else is pretty similar. I've got the CRDs that get installed into the cluster, just like you would with the Go version, which is telling the operator when to run its reconciliation loop whenever I submit one of these Operator Sdk kinds to the cluster. So that's essentially what the Ansible one looks like. So we'll go ahead and clean this out one more time, and then we'll take a look at the Helm version, which is going to look very similar to what Ansible is actually doing. When I initialize the project, we can see that I did the same thing as Ansible, except for I'm running it with the Helm plugin now. So nothing crazy there. We can see that this config directory exists again. The Helm charts is empty at this point because we've just initialized. So if I go ahead and create this, I can see that now I've got a Helm chart that exists in here, and with some templated things that exist in here that I could essentially take whatever Helm chart I wanted and place it in here and have it go ahead and apply that for me. And you can see that it's placed under the Helm charts Operator Sdk because I created this with the kind Operator Sdk. So if I change this kind, I would get a different Helm chart here as well. Other important thing to note, same thing as with the Ansible Docker file here. I've got a special Helm operator image that knows how to call these Helm charts during reconciliation. So that's how we would essentially go about introducing the reconciliation loop for a Helm chart. The magic lies within the image, not within like a special controllers directory like we have for the Go version. So essentially, in summary, for Operator Sdk is it extends out what Kubebuilder does by adding in the actual Helm and Ansible integrations on top of what Kubebuilder does with its typical Golang integrations, with scaffolding out the initial controller code and the API spec. Next, we're going to go ahead and move on to Operator Builder, which is the project that we have been working on. The final tool we want to go over here is a project that we've been developing here in-house at VMware here for a few months, and it's called Operator Builder. I wanted to point out that it is open source. It is publicly available under the VMware Tanzu Labs organization as Operator Builder, github.com/vmware-tanzu-labs/operator-builder. All documentation is currently within the repo on the main README page, so that'll get you started and get quickly. In addition to that, if you are a Tanzu customer, there is a Fling for Operator Builder. This essentially is a plugin to the Tanzu CLI, which will allow you to build your own operators using the Tanzu CLI command. So first and foremost, Operator Builder is based upon Golang, Kubebuilder, and it creates us generate a Golang code, which we're going to take a bit in a minute. It takes what Kubebuilder does initially, which we already saw, which is scaffolding out some code, and it actually generates a working operator based on a given set of manifests. So to get started here, you see a workload config directory here in my tree, but I'm gonna go ahead and just run my init command, and I can show you kind of what that means. So my make target runs my init command, and we can see that I'm running something similar to what Kubebuilder has done, except for now we have this workload config, and I'm pointing it at workload config workload.yaml. Let's go take a look at that real quick, and I can kind of walk through what's going on here. So that workload.yaml file is essentially what Operator Builder needs to tell it how to build your own custom operator. In this case, we are building a standalone workload. There's multiple types of workloads. I'm not going to go into those now, but they are documented on the GitHub site. With the same inputs that we put before, we just wanted to declare them in a file. This is the init inputs that we already put in previous Kubebuilder and Operator Sdk demos. In addition to this, we generate an actual CLI that can be used to actually manage the operator once it's generated, and we tell it, hey, which resources am I gonna create here for you? So, and at this point, we just have a resources.yaml file. If we take a look at that resources.yaml file, we can see that I've got a deployment, I've got an ingress, I've got a service. So this is a really simple web application that we're using to demo this. The important thing to note here is we have these markers, these weird little markers here that are designating essentially what is in the API spec that we generate. So in this case, I'm going to go ahead and modify the give the operator the ability to modify the spec.replicas field in this deployment manifest. And I'm saying that field name in my CRD is the web store replicas field. I default it to 2, and it needs to be an integer type. I can do this for whatever fields that I really want to. You can see I've got an image here. I defaulted that as well. Description gives us documentation via like kubectl explain, so I can explain my CRD and get nice clean documentation about what's happening with that field. So that's essentially how we mark up these files, and we tell Operator Builder what its API spec actually looks like and what is modifiable via whoever's consuming this custom resource that we generate. So that's essentially what one of those looks like. We can go ahead and now create the API based off of that. I run create here. We're going to go see some different things, same structure, but some different things we'll go ahead and point out here once this finishes. And I'll go ahead and go dump into the apps directory, and I've got the web store resource, and I've got this resources1.go file, which essentially is are my resources that I'm creating. You can see that my resource object from my resources file, now I have a deployment manifest, and this replicas field is managed via the parent spec web store replicas field like we just saw within that manifest. You can see this is a Kubernetes unstructured type, so this is just an unstructured object, and we are passing in this API struct to allow it to manage these specific fields that we have designated via the markers. that's one bit of interestingness. The other thing is if I go to the types section, we can actually see the API, which we've allowed the service name field to be modifiable. We've allowed the web store replicas field to be modifiable, and we've allowed the web store image field to be modifiable. So now I've got an actual full featured spec, an API spec for my operator that I can now modify at will via these resources and these unstructured types. But what really ties that all together is the actual control loop. So if I go to the control loop, before we saw just put your logic here. If I go to the control loop, I now see that I have a full functioning actual control loop that will run through an actual reconciliation process. And we've split the reconciliation process into several different phases, which we're calling them. And we actually set status on those phases. So you could go to your CRD, you could look at the status field, you can see maybe what part of the reconciliation loop this specific thing were to fail or have problems with, or get a status off of a specific phase. So we essentially did that for troubleshooting purposes. We're not going to go over that in this specific tutorial. We've got other demos that we can go over that with specifically. But the important thing to note is we now have a full featured reconciliation loop, which is going to generate these resources that we've generated into the cluster. So dump them into the cluster when it gets created. Upon update, the reconciliation loop is going to happen again, and we're going to ensure that these resources stay in this desired state that we have defined right here in this resources file. Everything else between Kubebuilder kind of remains the same. You're going to see all the same sort of structure here, the same sort of sample that we have. This is a generated sample, like what one would look like if I were to submit this to a cluster. Again, this isn't about demoing this. We'll have a different demo for that. This is just about showing you like what Operator Builder actually provides for you. So here's a sample with what one would look like. I could also do just like I did with the Kubebuilder demo earlier. I could make my manifests, in which case it's going to scrape the spec file and generate my CRDs for this specific custom resource. And that's essentially it. This is one we've been working on for a few months. This is one where we decided that if you wanted to be a person that manages your Kubernetes implementation via Go and to skip over the templating stuff, this would be a really good way to do that. So so go ahead and check it out, Operator Builder, on the VMware Tons of Labs org, and give us some feedback if you have any. We'll go ahead and conclude here in a second. Just want to go through a quick conclusion. Here's what we compared. These are a lot of common tools that are helpful for building operators in Kubernetes. This is just a quick comparison between the three we talked about. The first one is Kubebuilder. The important thing to note, it is the basis for both the other projects, Operator Builder and Operator Sdk. It will give you essentially a set of manifests and some scaffold Go code for you to get started. Operator Sdk, same thing. Scaffolded Go code is really similar. However, it does add the Ansible and Helm functionality to that if you want to manage your reconciliation loops in that manner. It also uses the Kubebuilder plugin model, which is again, Kubebuilder being the foundation for all of these projects here. And finally, Operator Builder, which generates a working Go code, gives you functional reconciliation, and allows you to create, update, and delete your Kubernetes resources via its reconciliation loop, given a set of manifests that you already have. And again, once again, that does use the Kubebuilder plugin model as well. So we are leveraging that to build upon what Kubebuilder has done. And we can go get it to go. Okay, and finally, the resources here. Just wanted to point out we've got the Operator Builder repo. Again, it's at github.com, VMware Tons of Labs, Operator Builder. Kubebuilder, you can probably just Google that one. That's a pretty big project. So github.com, Kubernetes SIGs, Kubebuilder, Operator Sdk, github.com, Operator Framework, Operator Sdk, another big one. So you can probably just Google that one as well. Kubebuilder, Operator Sdk have absolutely fantastic documentation you can go through and look at. So I'd encourage that, especially the Kubebuilder stuff, because it does go through kind of the fundamentals of reconciliation and kind of design decisions and best practices and stuff like that. So it takes it beyond just what Kubebuilder provides and talks about more fundamental ideas behind Kubernetes reconciliation. Finally, I did provide the code and the make targets and stuff that I generated via the demos repository. So you can go ahead and take a look at that if you want to get maybe a better idea of what happened during this demonstration, so you can maybe play with it yourself if you would really like to. On that note, thank you for watching, and hope this was informative for you. Thank you.